This session will give a brief introduction to CCDAutoPilot. In this session, we will set up a target to be acquired, some calibration frames, and start the session. We'll check back in on it from time to time over the course of the evening and review the results of the session in the morning. So to begin, since we're in a planning mode, we'll check planning only and link to our software, which at this time is simply the Sky X. So what we're going to do is I want to take an image of M109. So I'll enter that, hit return, select a template, more about this later. M109 is now entered. I'll hit the update button to update the database. Once that is done, I'll right-click on the target name to bring up the context menu and select. We're now looking at the sky, and we notice that we have our field of view indicator down here, and there's no guide star nearby. However, there's a nice guide star right over there, reports a magnitude 9.6. So what we're going to do is we're going to rotate the field of view indicator and then translate the field of view indicator such that that guide star is now centered in the field of view indicator for the guider. We'll switch back to CCDAutoPilot, and we'll now hit the Get button with nothing entered in the space. Again, we'll select our Galaxy template, and now we have a target which has a position angle and a slightly different set of coordinates. Let's look and see what that looks like in the sky. And now we have our guide star right where we want it, in the center of the field of view indicator. We can go back here, delete this target, which we don't need. We'll double click on the target name and rename it to something useful, like M109. And we'll update that. Now what we'd like to start, given the transit time of the targets and ambient light conditions, we might like to start around 9 o'clock. So we'll do that. So our light frames are going to run from 2100 to 318 in the morning. We should get some dusk flats. So we'll use a template, more about these later, set up for eastern sky and see how it fills out the data here. We noted that our M1 position angle is 21.3, so we'll end up 21 here, and we'll update this. So now let's look at the Darken Bias Frames tab before the Light Frames tab. We see our light frames don't start till 2100. We have times from civil dusk until then to do something. So let's go get some calibration frames. So maybe we'll get some 1x1 600-second darks and biases. If I put in 5 and update, that will take me to 2007. I can get a couple more, maybe another 2. Now 2028, one more. And now we have 8 darks, as well as a collection of bias frames. We'll do the same thing after the light frames, because again we have from 333 to 540 before anything is going to happen. So let's get some 1200-second darks. After we update, we see that that will take us up to 523. And lastly, we should get some dawn flats to match data taken on the other side of the meridian. So we're going to get the sky west. Again, we want to put in 21 degrees for our rotation and update that. Now we ought to reset or set up our guiding and focusing, so we'll go into guiding, and I always dither. We'll allow CCDAutoPilot to suggest dithering based on our guider binning and our imaging plate scale. It recommends 1.3 pixels. We have auto exposure set to go between a minimum and maximum for a target ADU of 3000. That looks good. Focusing. We'll select SkyStar focusing, which is our off-target focusing. And maybe we should refocus on a temperature change of every 2 degrees. And that looks pretty good for focusing. We'll check our options, and we're going to begin 15 minutes before sunset. We're going to have our cooler set itself to minus 40 for the imager, minus 10 for the guider. During the data acquisition phase, we want to wait till civil dusk before we take our darks. After the light frames, we're going to park the telescope. While we are not doing anything, we're going to have the tracking turn itself off. We're going to abort any light and dark frames at dawn, park the telescope after the dawn flats, run this little program which puts my telescope more conveniently for closing my roof, and raise the cooler set points by 30 degrees so that they won't work extra hard during the day. There's no need for it. So with that, we'll review our session. And session cannot be run because we're in planning mode, which we knew. And just scan down all the times and look at all the settings and all the information. This is mostly diagnostic stuff. So let's go back one time, disconnect, set uncheck planning mode, and now this will connect CCDAutoPilot to all the equipment, or more specifically the software for all the equipment, so that it can control all elements of the observatory during the course of the evening. Everything has completed connecting. We go into our run session. We get a little snapshot of the weather conditions, where the coolers are right now, because they're at their warmer temperatures because we haven't started our session yet. And we'll click our run session button. And we can see that it's waiting, and we're waiting until 6:27 p.m. to begin our session. In the course of the session, this information over here will be filled in if you want to watch it. There'll be a status window down here that will have what's going on, whether it's exposures or waiting, in this case 146 minutes. So we'll join this a little bit later. Our session is now started. The cooler temperatures have been set to minus 40 and minus 10 for the imager and guider respectively. After waiting for dusk, we're now in the twilight session, where we're waiting for the sun altitude to get low enough. The sun altitude has now arrived at minus 0.5 degrees below the horizon. CCDAutoPilot is slewing the telescope to the null point in the sky. This is a point of maximum flatness for taking flats. So it's slewing the scope to that point, and once it arrives there, it will begin to run test exposures to achieve the desired 30,000 ADU target count that we set in the dusk flat session. The rotator has moved to the rotation angle corresponding to the desired position angle of 21 degrees for an eastern meridian mount, and it's beginning a test exposure at 13.4 seconds. The intent here is to adjust the exposure and or wait for the sky brightness to dim to the point where CCDAutoPilot can run exposures that will meet our 30,000 ADU level. At this point, we're too bright, so Autopilot will wait for a minute and try again. In reviewing our session, we see that our flats have been acquired by CCDAutoPilot adjusting exposures as needed to meet the target ADU count. We see the various green, blue, and ultimately the luminance flats coming in. And we're now in the process of collecting our darks. You can see the progress bar exposing 4 out of 8 dark frames at 600 seconds, one by one through the red filter. At this point, our darks and bias frames have completed. It's now 2038, and we're waiting for 2100 to start our light frames. We'll check in with that shortly. Our session is now starting. The target ephemerides have been defined, and the scope is slewing to the target. Autopilot is ready to start the first series. However, there's a focus at series start scheduled, so Autopilot will now salute to a focus star above the specified minimum altitude of 60 degrees and focus on that star using the red filter. Focus is now complete. The focus half flux density is reported at 3.0 arc seconds. Focus position of 12714, a temperature of 18.1 degrees C. Telescope is now moving back to the target and will do a precision slew to ensure precise positioning and acquisition of the guide star. The initial pointing error is identified in the log, the location is corrected, and now we're getting the guide star location and exposure. We have some thin clouds here, so the exposure is a little longer than would be expected. We have finally achieved our guide error tolerance, and the exposure is now beginning. We'll check back in the morning and see how the session ran. It is now morning. Our session has concluded. We can see that the telescope has been parked, our final script was run, and the cooler temperatures were raised by 30 degrees. We've compressed almost 12 hours of automated operation into a little under 12 minutes, so you can see CCDAutoPilot operating over the course of an evening.